So here's one additional video where I'm going to go through an answer for momentum impulse and conservation of momentum for our quiz. So it's number 12 on the practice quiz. So right now, if you haven't already done the problem, try pausing it and setting it up on your own to see if you can solve it on your own, to see where you might be stuck if you can't solve it on your own. So start by identifying variables. We have Anand here, and he's in PE class playing basketball. He makes a layup and collides with the padded wall behind the basket. So look at, why do they have padding? What does that do in terms of a collision? He's 80 kilograms, so put a box around that, and put M right below it. That's the measure of mass. He slows down from 10 meters per second to 0, so that means his initial velocity is 10, his final velocity is 0, and label those appropriately. So box around the 10 for v sub I, or initial velocity. Box around the 0 for v sub f, for final velocity. And then we have 0.2 seconds, a measure of time. So you put a box around that and write t. Determine the amount of force acting upon Anand's body. We have two main formulas we've looked at here. P equals mv, no force is present in that formula. And then we have J, impulse, equals ft. So there's force present in that one. So that's likely going to be the formula we want to use. We also know that that impulse is the change in momentum. So we're going to have to probably use that to figure that out. Let's start with the easiest part. The final momentum is 0 because his speed is 0 when he stops. So he comes to a complete stop. He loses all of his momentum. So that's the impulse is going to take away all that momentum. We have 80, his mass, initially times 10 meters per second. So he had 800 kilogram meters per second before he collided into the wall. Now he loses all of that. So the impulse is that change in momentum, or 800 kilogram meters per second, because he comes to a stop. So we set it up, J equals ft, and we know that impulse equals 800 because all of the momentum is lost. We know the time is 0.2 seconds, so I substitute in 0.2 for time. I get 0.2 times the force equals 800. When I divide both sides by 0.2, I get that the force on his body is 4,000 newtons. Now, what would happen if instead he hit the concrete wall and the impact was 0.01 seconds? So a much smaller impact time because the concrete doesn't give, whereas the padded wall does. So in this case, it's the same formula, except for now we substitute in 0.01 for the time. So he still loses 800 kilogram meters per second, so that's the impulse, or change in momentum. 0.01 times the force equals 800. When we divide that through by the force, we find that his force feels 80,000 newtons of force. A lot more force. So that padded wall really does a lot to lessen the force that he experiences by extending the time of the collision. Similar to the idea of bringing the water balloon into your body, as you caught it in our lab, to lessen the force on the balloon and lessen the likelihood of it breaking. Okay, go through the other problems. Remember, there's a video where I also did number 10 and number 11 for you to review. The key to remember is that impulse is a change in momentum, and that momentum, P, equals mass times velocity, and impulse, J, equals force times time.